Dear students, we may get a question like this. What is an adiabatic process? Obtain an expression for work done by an ideal gas in an adiabatic process. What is an adiabatic process? A process in which there is no exchange of heat energy between system and surroundings. Okay. See, now here we have taken some gas. If you pull the piston to right hand side, then the volume of the gas expanded. So this is expansion. When volume expands, when volume increases, pressure decreases and temperature also decreases. Suppose here surrounding temperature 27, ideal gas at 27. System and surrounding both are at same temperature, and when you pull to the piston outside, the temperature has fallen to some 24 degrees centigrade and surroundings at 27 degrees centigrade. Now what happens? Heat always tries to flow from higher temperature region to lower temperature region. But this time cylinder wall is made of insulator. Insulator means a bad conductor of heat. It doesn't allow heat energy to move from surrounding to system. So it means what? In adiabatic expansion, there is decrease of temperature. Okay. In this example, piston is pushed into the cylinder. So the volume is decreased. That is, it is compressed. When you compress the gas, then pressure increases. Temperature also increases. Here, suppose here the temperature is some 27 degrees centigrade and surrounding also 27 degrees centigrade. Now this has become 30 degrees centigrade and here only 27 degrees centigrade. Now heat energy tries to flow from higher temperature region to lower temperature region, but here cylinder wall is insulated. It is insulated so that heat energy cannot move from system to surroundings. So in adiabatic compression, what is happening? The temperature of the ideal gas increasing. In adiabatic expansion, temperature decreases, and in adiabatic compression, temperature increases. Now let us find expression for work done in adiabatic process. Work done is dW is equal to PdV. This is the expression. Now, but adiabatic process obeys a relation PV power gamma is equal to constant, where gamma is equal to Cp by Cv. Previously we discussed isothermal process. Isothermal process obeyed Boyle's law. Just like that, adiabatic process obeys this relation. And this is constant, therefore let us write is equal to K. Now, this also can be written as P is equal to K by V power gamma. Let us substitute this in first equation. P V power gamma is equal to constant. Let the constant be K, and then P is equal to K by V power gamma. Let us substitute this value in first equation. Integrating on both sides. V power gamma brought to numerator. Integrating dW, we get total work done. And here V is a variable, and for integration we have to mention the limits. From which limit to which limit it should be integrated. If you consider adiabatic expansion, initial volume is V1, final volume is V2. So from V1 to V2. W is equal to K. Now this must be integrated. There is a mathematical formula. If you integrate x power n, you get x power n plus 1 by n plus 1. This is the formula. So here in place of n we have minus gamma. V power minus gamma plus 1 by minus gamma plus 1. After integration, we substitute the limits. One minus gamma, this is a constant, so let us write here. Now, substituting upper limit, we get P2 1 minus gamma and minus, substituting lower limit. Let me send the k inside the bracket. But P v power gamma is equal to k. This suggests us that P1 v1 power gamma is equal to P2 v2 power gamma. Therefore, here in place of k value, we can substitute this value. And here in place of k value, you can substitute this value. Now here in the product of these two terms, we add the powers. Here plus gamma, here minus gamma gets cancelled. So that is, we write like this. Let me write here gamma plus 1 minus gamma. Plus gamma minus gamma cancel. Minus gamma cancel. But ideal gas equation is PV is equal to mu RT. P1 V1 is equal to mu R T1 and P2 V2 is equal to mu R T2. Substituting these values, we get in third equation, P2 V2 plus, you will write this. In place of P1 V1 we write mu R. Gamma R can be taken common. But here gamma is greater than 1. Hence, let us multiply numerator and denominator by -1. So this is the expression for work done in adiabatic process. According to first law of thermodynamics, delta Q is equal to delta U plus delta W. But in adiabatic process, there is no exchange of heat energy between system and surroundings. So take this delta W this side. And just now we derived expression for delta W, sorry, work done. Here you can see we got W is equal to mu r T1 minus T2 by gamma minus 1. Say this is fourth equation. See, this is adiabatic expansion, and here the gas itself moved the piston. So work is done by the gas. Therefore, W is positive. Now change in internal energy is equal to minus delta W. So if this is positive, minus into plus minus, so this tells you delta U is negative. Delta U is negative means what? Its internal energy decreases. If internal energy decreases, its temperature decreases. So in adiabatic expansion, its temperature decreases. Temperature decreases means initial temperature T1, final temperature T2. See here T1 is 27 and T2 is 24. Temperature decreased. you can arrive at this result in another way also, using this equation. How? Here you got work done is positive, no? So applying this to this equation, how we can say? If W is positive, this is positive. That means T1 minus T2 is positive. Or T1 greater than T2. Or T2 less than T1. It means what? Temperature is decreasing. Okay. Now let us consider adiabatic compression. Now let us consider adiabatic compression. So here work is done on the gas by us. So according to sign convention, since work is done on the system, work done will be negative. Since work is done on the gas, work is done on the gas, therefore work is negative. Okay, so W is equal to mu r T1 minus T2 by gamma minus 1 is negative. This represents T1 minus T2 is negative. This represents T1 is less than T2 or T2 greater than T1. That is, there is increase in temperature. So in isothermal compression, the temperature of the gas increases, and since there is increase in temperature, there will be increase in internal energy. Now, what conditions are required to have adiabatic process? Number 1, walls of the cylinder must be made of insulating material. Second condition, during expansion, piston is moving to right hand side. During compression, piston is moving to left hand side. So the movement of the piston must be rapid. Piston be moved rapidly. Why rapidly? If you move the piston slowly, if you move in adiabatic compression, suppose you are moving the piston to left hand side. If you move the piston slowly, there is a chance of some of the heat moving to the surroundings. That's why to prevent heat exchange, it must be moved rapidly.